These little triangles right here mean what?
Parallel.
Parallel. Okay? No, it just says it right here. Okay? So, yes. Oh. Let's get back to this. So, triangles being they're parallel. Okay? So if I have two triangles, if I have a line, all right, to one side of the triangle, then it divides the sides into proportional parts. And what that means is you can set up a couple of different proportions here. We did this earlier where we said that AB corresponded to AC, and then we would have AE would correspond to AD. All right? In this theorem, you can say, well, because these are parallel, then AB is going to correspond to BC, as AE would correspond to ED. Okay? We're going to skip this if-then thing. Okay? That's just the proportion. It's basically saying, look, if this is parallel to this, then AB corresponds to BC as AE corresponds to ED. So the example would be set right here. Okay? If AB is 12 and AC is 16, ED is 5, and we want to find AE. Okay? So I can set the proportion up that 12 is going to correspond to 4, right? Because if this is 12 and this is 16, this is 4. So 12 corresponds to 4 as x corresponds to 5. So 60 equals 4x, x equals 15. Okay? You with me? So if this is parallel to this, then this over this equals this over this. Right? Now, stay on this same picture for a second. Okay? If this over this equals this over this. All right, let's just go back to here for a second. If I say I don't know that these are parallel. Okay? So, but this is 12, this is 4, this is 15, this is 5. Okay? If 12 over 4 equals 15 over 5, then I know these two lines are parallel. So it's just going backwards. If they're parallel, this over this equals this over this. If this over this equals this over this, then this is parallel to this. That's all it's saying. So that's what this converse says right here. Okay? The converse says, look, if AE over EB equals CD over DB, then AC is parallel to ED. That's all that's saying. You with me? Good. All right, so triangle ABC, BC equals 15, BE equals 6, DC equals 12, and AD equals 8. Determine whether or not DE is parallel to AB. All right? If these two lines are going to be parallel, then this proportion has to exist. If we cross multiply these two, then, well, 15 minus 6 is 9. So therefore, 72 equals 72, because I just cross multiplied these. You can reduce the fractions too. You're just showing that they're equal to each other. And so because they're equal to each other, these two lines are parallel. Fantastic. Mid-segment. Okay? If I find the midpoint of each side of the triangle, okay, then if this length is 10, this length is 5. That's all that means. Okay? If this is the mid-segment, then the larger side is twice the value of the smaller one. Okay? but they have to be the midpoints. Let's look at an example. Okay? So again, it says that DE, 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 and EF are midsegments. Hmm? This is a midsegment, and this is a midsegment. So what's the value of AB? 10. What's the value of EF?
5. I can't see that.
9. Because this is 18. So if this is the midsegment, this is 10. If this is the midsegment and this is 18, then this is 9.
Yeah.
All right.
I can't see that.
Well, then move. I mean, I got a desk right here in front of the screen. Okay.
I'll sit there another day.
All right.
Yeah, I do.
Can you see this one? Okay, hang on. Let me make it easy for you. Hang on.
That makes it a lot easier.
Well, I'm here to make life easier for you. That's my job. What's the value of X? Look. Whatever. All right.
It's okay.
So
I'm getting glasses. Well, I'm getting contacts. But
if these lines are parallel to each other, then I can still set the proportions up. But I can do them a little bit differently. I can say that AB corresponds to BC as EF is going to correspond to FG. I can also say that AB is going to correspond to EF as BC is going to correspond to FG. Okay, I can do them both ways. All right, so let's look here. Solve for X and Y.